Okay, so welcome back. A couple of announcements to get started. First of all, group formation is due tomorrow, so please go to Piazza. That's where the link to the Google Forms is for letting us know what your group is. Welcome, Jeff. Thank you. So if you don't have a group, I noticed that there's been a lot of discussion of, hey, I need a group, I need a member, I need a partner for the group. Please take care of those. Obviously by tomorrow. If you can't find a partner to pair up with, we'll pair you up, I guess. I'd rather you choose so that we don't have to do as much work. So by the way, guys, this QR code is attendance for today. So you need to scan it and log in. What else was I trying to say? So the other thing about groups is that when we do in-class exercises, you will need to sit next to each other. I'll try to when we do an in-class exercise, it'll be really obvious because we'll have a gigantic cart of laptops. So on those days, you will know that you need to sit next to your partner. So okay, that's enough about that. So speaking of Piazza, not everyone is signed up last time I checked, so please go to Piazza. The link is on the course website. That's how we will get information to you. So please sign up. Okay, so this one's kind of a big one. I need to change the date of the midterm exam. I don't have a firm date to put it on quite yet, but it probably will not be the week before spring break. I hate to have you come back from spring break and give you an exam, but it's looking like that might be what works the best. So I will keep you updated. I will update the website and send announcements out. Is that a good thing? Yeah? Okay. Yeah, what's up?
Will the midterm be more difficult because we have spring break, or will it be like the same level of difficulty,
I have not considered how I will change the level of difficulty of the exam based on the date.
Can you consider it and then not make it more difficult?
I will consider it. I won't make any promises though. Okay, any questions about those announcements? Anyone still need help taking attendance, showing that you're here today? Anybody else? You've kind of said that you're here today? Or you're kind of here today?
I'm logged out of my Gmail, and I try to add my ASC email because I just forwarded it to my Gmail. And then every time I try to log in, it says this isn't a Gmail account.
Okay, so what I would do, if I were you, get the URL up, email it to yourself, and it'll be easier on your laptop since you have a laptop open. All right, let's go ahead. Anybody else still need this up, or can I put it away? Okay, please hurry. All right, so let's review from last time. What are 3 ways that a computer can be involved in a crime? 3 ways.
Assisted.
Computer assisted. So yes, I'm trying to think of the easy. Yes, is that the? Man, you got me on a bad day. I had like this terrible fight with JavaScript today, like all day. So like my brain's a little bit mush today. I apologize. Okay, computer assisted. So where the computer is a tool to commit the crime. Is that what you're thinking?
Yes.
Okay. What's another way that a computer can be involved in a crime? Yes. Targeted. So it can be the target of a crime. Yeah. What's the 3rd way?
It can be used to store data or information that's obtained illegally.
Exactly. So a computer can either be what launches, helps you commit the crime, what you use to commit the crime. It can either be, or it can be a target of the crime, or it can be incidental to the crime itself. It's neither the crime or the perpetrator, or the victim, not the perpetrator or the victim. So for example, it's not illegal to have a list of your drug buddies on your computer, right? That's not the crime. The crime is the drugs, right? So that's why that's incidental to the crime. Does that make sense? Any questions on that? Okay. What is the deep web? What's the deep web? Anything behind a login. I love how simple that is. Yes. What is the dark web? Tor. That is the simple answer. So yes, anything on Tor. Now, you can get to Facebook on Tor. So not necessarily everything on Tor is evil. Well, I don't know that Facebook was the best example of that, but that's the dark web is Tor. Okay. All right, perfect. What are some of the reasons why forensics wasn't very big in the early days of computers? Why wasn't it a big deal?
Because forensics. Yeah.
Okay, yeah, so digital forensics had its origins in data retrieval, and now it's kind of the only purpose. What else? Why wasn't digital forensics a thing when computers first came out? Like with Grace Hopper and all that, yeah.
Because that there weren't actually laws.
Ah, very good, yes. So we talked about how you can't commit a crime unless there's a law or a policy that says don't do that, right? That's a very good reason. Excellent, I like that. Yeah.
Format of information storage was so vastly different across every machine that it was hard to have some standard.
Yes, so what you said is correct. The reason why there wasn't forensics though wasn't because there were lots of file formats, right? Right. So what were the conditions that made it so there wasn't a need for computer forensics? Do you see the difference there? What were the conditions? There's one more that I was thinking of. Yeah. Opportunity to commit crime. Yeah. So committing crimes with computers wasn't really a thing. Right? So until people started to figure out that you could commit fraud by taking advantage of rounding errors in banking software and things like that, there was no need to do forensics because there weren't any crimes being committed by them. We were just sending people to the moon, right? Okay, what circumstances made the golden age of forensics so favorable? There's a few. God, you remember the golden age of forensics? It started about 1999? Yeah.
Everybody used the same operating system.
Everybody, which one was it?
XP.
Windows XP, like everybody used it, right? They were like these super artsy hipsters that were stuck to their Macs, right? They were like weird shapes and stuff like that, right? That pretty much everybody used XP for everything. What else? What was another reason? Standardized file formats. So things started to get really standardized because everybody was using the same operating system. So you had Office, which just Microsoft Office dominated the market space because everybody was using Windows, right? Okay, what else? What other reasons? Yeah. Give me more words. What do you mean by that?
People were finally able to access each other correctly.
So that helps us be able to do forensic better? Is that what you're saying?
Yeah, mostly because, well, they helped us be able to do it better because we were finding more and more ways that people were perpetrating these crimes and pushing people.
All right, I'll buy that. Yeah, what else? Yeah.
Everyone's going to have their own person.
And how many did they have? Yeah, everybody started to get computers, but they really only had one. So they didn't have a cell phone and a work cell phone and a tablet and like we do today, right? There wasn't taking somebody's TV and doing forensic analysis on it. That wasn't a thing. There was no data on it, right? But today, did you hear that cheap TVs are cheaper? Sorry, smart TVs are cheaper than non-smart TVs because advertisers are tracking your behavior and subsidizing the cost of the actual TV. Did you see that headline this last week? Isn't that crazy? The world is crazy. Okay, let me check my list here. Okay, there's one more that I wanted to kind of focus on as far as like one of the circumstances that helped make the golden age of forensics so productive. Anybody think of it from your notes? Yeah. Yeah, we talked about that one. Looking for another reason. Yeah.
Was it like the storage interfaces or something were standardized, like the ports?
Yes, that is one of them. Yes. Yeah. There's one more. That was a good one. We started to have good software to do the forensics. So FTK, NCase, these and the sleuth kit, which is open source, all these things came out and they were actually helpful for the kinds of crimes that were being committed on computers. Okay, that was the last thing. Okay. I'm going to skip that one. Okay, a major step in forensics, one of the processes is to retrieve data. What conditions might the data be in that would make it difficult to analyze? You understand the question? Yeah.
Damaged or destroyed.
Damaged or destroyed, yeah. What else? Yeah.
Fragmented.
Fragmented, very good. What else? Encrypted, yeah. Deleted. Corrupted. Blown up. Soaked in acid, right? Lots of different things. I mean, I say that, it's kind of funny, but really that's what happens, right? People try to destroy digital evidence to hide their crimes, and that they do these things. Very good. What are the three parts to the main objective of forensics? Okay, if you're gonna do forensics, you're really kind of identifying three things. This seems a little obscure, but it's simpler than you might think. At a more conceptual level.
Was there a crime committed?
Yes, what happened? When it happened, and who did it? Yeah, sorry, that was kind of hard to word so that I could kind of pull it out of you. But yeah, if you're going to do forensics, what you're focusing on is who did what and when did they do it. So those are the three things. Perfect. What is the Fourth Amendment to the United States Constitution? You don't have to recite like verbatim.
Something unreasonable search and seizure.
something unreasonable searches and seizures. Yes. So it provides for the protection of the people in their papers, their properties, their effects, all this stuff from unreasonable search and seizures. And what do you have to do to be searched? What makes it reasonable? You got to have a warrant based on what? So close. Probable cause. Probable cause. That's the legal terms. Okay, perfect. Okay, why do we have to pay attention to the Fourth Amendment? Do we have to ignore it? Yeah.
You don't follow it when collecting evidence or evidence isn't admissible to court in your case.
Yep, totally useless, right? The way that our evidence actually makes it in front of a judge, a jury, somebody, some decision maker, if it's not like a civil case or a criminal case, is you have to protect it. You have to follow the rules when you're analyzing it. Perfect. Okay, so that wraps it up for our review for today. Oops, sorry. Okay, so last time we left off talking about different types. Yeah.
Did you start recording this?
I did.
Okay.
It's okay. So the thing is, we see what time people submitted the form, so it's all good. Okay, so last time we talked about the different types of forensic evidence, right? Of digital evidence. Which one of these freaks you out the most? This is a very personal question. Which one? IoT? Car. Yeah, those freak me out pretty well too. Okay, so when we're dealing with evidence, there's a few different types of evidence that we have to deal with, right? So first of all is archival. What is archival evidence? I know there's a definition up there, but use your brain. Like, what does it mean? What is it? Why would I say, okay, this evidence is archival versus that?
I guess archival data is like data that isn't, like, I guess, being used. It's not that it's not being used, but it's like in storage or like it's in a backup that someone's made their archive.
Absolutely. So you might think that the term backup tapes is archaic, but actually tape storage is today still one of the most reliable storage methods, mediums to store data. So although, well, yeah. So archival data, sometimes if the device is so destroyed or damaged that you can't pull anything off of it, there might be an archive somewhere, a backup. But that requires you understanding the system, how it was set up, what other systems it talked to, and things like that. Active, of course, that's what's currently being seen. And then we have this term forensic, which we talk about as data has been removed from the operating system's view, also known as unallocated space. So this is if you have certain, if you're trying to hide your activities. Now, I guess I should pose a scenario here. But whenever I talk about like hiding things in weird places, you have to think that this is like malware, right? Something that is actively trying to hide itself from somebody that's looking for it. Like your average like drug dealer or somebody isn't gonna know, okay, I'm gonna change the partition sizes on my hard drive but actually store stuff there. Like they're not gonna do that, but malware might. Okay, so it sounds a little bit far-fetched or weird, but really there is a case for it. So, but that's the kind of place where we need to be able to pull data from to get forensic type data. Okay, so here are the things that we need to know to be able to pull this data off. First of all, file system and operating system. We need to this goes back to what we talked about last week, that you have to have that deep technical understanding of the system, how it stores stuff, how it operates, what happens when you delete a file. By the way, if you don't know, if you delete a file, it doesn't actually zero fill that space on the disk that was allocated for that file. It just has like this index of what files are on the system, and it just says, okay, this is now deleted. It's just like a flag. This is a lot faster, right? So, okay, and then understanding data, sometimes you have to pull up a hex editor or do binary analysis to really understand what the system is doing, how it's storing data. And you've got to have a basic understanding of operating system commands. So how many of you have used a hex editor before? Yeah? Okay. What are some of the use cases? Why were you using a hex editor?
I don't know, I'm just looking for, what's the part of the challenge?
So you were like doing a capture the flag competition or something? Okay, cool. Yeah.
The game save files, or something.
Nice. Why were you using it?
Like modifying it.
Oh yeah? To do what?
I like testing on it, like it would itself.
Oh, very cool. One of the most stressful times I had to use a hex editor this was back when I had a MacBook Pro, and the partition table. We'll talk about what a partition table is pretty soon, but it got so messed up that I literally had to go in there and manually change the values in order to be able to be sure that it could boot the next time. So that was a little bit scary, but it worked. So it was pretty. Okay, so some of the tools that you might need when you're doing forensics are these. These look kind of crazy, right? Not really software based, right? But this, I don't know if any of you can read this. I should be able to like click on it and oh no, that's Prezi, sorry. Got two different presentation systems on mine. So this says electromagnetic field. The the purpose of a device like this is to basically create a barrier for radio waves, right? So another thing you could use instead of a device like this is something called a Faraday bag. Who knows what a Faraday bag can describe it? Yeah.
It's like a, kind of like a metal bag.
Uh-huh.
But any device.
Exactly. Yeah. So your phone, the way that it communicates with cell towers and with the network and everything like that, it's all radio based, right? So if you put it inside of a bag that prevents any radio waves from getting out or in, you can be more sure that the state of that device will not change by the suspect, by the owner of that device, right? Because maybe they have some script set up to remote wipe their stuff if they don't check in or something like that, right? So that's actually pretty common. Using gloves so that you don't have like fingerprints and stuff like that. This is actually two pictures of the same thing. I believe what this is actually a chip-off system. So I grew up with like disk platter hard drives, right? But today, most of the laptops in this room don't have hard disks with spinning platters anymore. They're all solid state, right? Well, how do you get to those solid state drives if they're soldered onto the motherboard? Well, you have to unsolder them from the motherboard. And that's what these kind of tools do. This really old computer, believe it or not, sometimes criminals will use outdated systems purposely so that it's harder to analyze the data that's on them. So it's actually quite valid to have a lab that's very modern, but that has older tech in it so that you can analyze zip disks. Anybody have zip disks when they were a kid? One person, yes. Okay, I'm not the only one. Great. Okay, so let's talk about some forensic software that you need in a lab, right? First of all, a clean operating system. If you don't know why you need a clean operating system to do forensic analysis, no, I'm just kidding. So you also need some disk image backup software, and we'll talk, let's see, in the next topic. So topic 2, we're still on topic 1. In topic 2, we'll talk about various types of forensic imaging software and what they do and the differences between them. Search and recovery utilities, these are just like really high level basic stuff that I'm not going to test you on, so you don't have to scribble all these down if you don't want to. Just saying. File viewing utilities, that seems obvious too, but when you don't have, when the system you're analyzing no longer has a running operating system, there might be files on there that are difficult to interpret what they are. Like, I don't know if you've ever tried to, if you've looked at the internals of a PDF, but it's not human readable, right? You need something to help you figure out what is in that file. And that's the kind of thing that we're talking about here. Cracking software. Why would you need cracking software? I guess a better question is, what is cracking software? Cracks passwords, yes. Why would you need that?
The Windows logins.
Yeah, to log into the system, right? So some versions of Android and iOS, they have a pin, right, to lock the phone or whatever. And some of them you could try a pin, but it wouldn't actually register with the system that you had attempted a pin for like a certain delay of time, right? So it would tell you it was wrong, but it wouldn't log it in the system. So you could actually cut the power to the phone in that window of time and not increment the number of failed attempts to log into the into the phone. So that kind of thing, that would be considered cracking software. You'd have to have like a camera with optical character recognition set up and everything. So kind of cool stuff. Okay, archive and compression utilities, so on, blah, blah, blah. Okay, this is a little bit more interesting. Sorry, we had to get through all that, but let's talk about the difference between public investigations versus private investigations. What's a public, who wants to take a guess? What's a public investigation? Yeah.
An investigation that's been like going to like give information on it. I don't know, like say Marriott got hacked and everyone knows what the people people researching it are like kind of doing to.
I like where you're going, but it's the wrong answer. So, but no, that's good. Yeah. Perfect. Yes. So a government agency like the FBI or the Phoenix Police Department is doing the investigation. So we're talking like public sector versus private sector. Think of it that way, right? Public sector is government. Okay, so the laws of search and seizure protects the rights of all people, including people suspected of crimes. Again, it doesn't look very good on the when it's projected, but that's a copy of a warrant, right? You've got to abide by that Fourth Amendment. Another thing about public investigation, basically, it's a law enforcement agency doing the investigation. So if you're assisting with this, you have to understand the laws that affect that dictate what it means to handle evidence properly, right? You've got to understand the legal process and how to build a criminal case. All these are required to conduct a public investigation. Another thing is that, historically, computers and networks were seen only as tools in a crime, and the analogies with more traditional kinds of crimes, it took a while for the laws to catch up. We kind of already talked about that, but the states have since adopted specific language to be a little more up to date. Okay, so here's the process for criminal legal process. First of all, there's a complaint. Someone has to file a complaint. Basically what that amounts to is someone says, hey, this person broke this law, right? If I don't call the police up and say, my house just got burglarized, someone broke into my house, how are they gonna know that it happened, right? So there's gotta be a complaint, the officials have to be notified somehow. Then there's investigation, and a specialist investigates the complaint, figures out if a crime really was committed or if it's just someone being annoying or whatever it might be. And then proceeds on to prosecution, where the prosecutor collects the evidence, builds a case, etc. Okay, any questions about what we've been talking about? Okay, so law enforcement, you think about your average police officer. What would you guess is their typical level of technical expertise? Low to average, yeah. That's a really good way of putting it, right? So do you think they understand how a hard drive stores data? Or what it means that this file system is different than that file system? No, right? So this level 1 street police officer, really all they're able to do is acquire and seize the digital evidence. That's really all they have the capacity to do, but you have to train them how to do that correctly, right? I've heard law enforcement personnel talk over and over again about how people that were involved in investigation didn't understand the correct procedures and contaminated evidence because they weren't, they either forgot their training or were not properly trained. Like, for example, some suspect's computer was seized as part of an investigation, and the suspect was like a big time gamer. So really sweet PC, like decked out, like internal lights, the whole, everything, right? And some guys in the lab were like, I bet he's got some really cool games on there. So what'd they do? They fired it up and played games on it. Not realizing that even though they weren't touching files that were possibly connected to the case, they were contaminating the evidence and making it completely inadmissible in court. All right, so that's this level of understanding as far as expertise. Okay, level 2 is like the detective. This level of law enforcement, they can manage the high-tech investigation. They have like an appreciation for the things that you've got to look out for and be careful of when you're collecting evidence, when you're handling evidence, and they. I feel like I didn't finish that sentence. Teaching the investigator what to ask for. Moving on, understanding computer terminology, so they understand at a high level. and what can and cannot be retrieved from digital evidence. So they understand. They may not know how to extract evidence of all kinds, but they understand that, like with the Alexa case that we were talking about last week, that there's a chance that in the buffer of the chip that processes voice commands, there may be something cached there that's worthwhile. They understand that at a high level. The third level is the digital forensics expert, and this is like the specialist that has lots of training. They might have training in a very specific area. Like one time I met a guy that was in charge of all the chip-off investigations for Phoenix, right? So he had his little space, chip-off machine over here and everything, and that if an investigation involved pulling chips off of a board, he was the guy that they went to. Okay, so private sector investigation. So what are private sector investigations? I'm mostly asking questions to keep your mind occupied. Move over here. Private sector investigation, yeah. Exactly. So does a private sector investigation necessarily mean that there has been a crime committed? Getting some very unsure shades. Why not?
They could be looking for if there was a crime. Might not be sure.
Okay.
Just simply looking to make sure that they have the proper procedures set in place as well.
Yeah, exactly. Yeah.
They're not bound by the law.
They're not bound by the law. Yes.
I mean,
What do you mean by that?
okay,
Let's expound on
It is
that.
not a legal investigation, so therefore a suspected crime is not necessary for that investigation to be occurring.
Right. So let's say, yeah, go ahead.
Maybe they are looking to see if there was like a loss due to like bad hardware or something. So it's not like
Yes.
any sort of illegal.
Like anybody did anything wrong, they're just trying to figure out what might happen. Exactly. Yeah, very good. Yes.
That's a great
Yes. So there has to have been some policy that was broken or that they suspect was broken. Very good. So one really great example is that, maybe for some reason a company decides that all Google sites are banned, right? They don't want anybody to use any of Google services, okay? And they suspect that somebody found a way around their firewall rules and was able to get to Google. Does that mean the crime was committed? No. Does that mean that their policy was violated? Possibly. So there's no way that they would refer that kind of investigation to law enforcement, but it might be worth investigating so that they know whether to let the person go, whatever. Okay, deals with private organizations, not government, and not governed directly by criminal law or the Fourth Amendment. So that's actually a really important piece. As we talked about earlier, internal policies are what define acceptable behavior. So private investigations are usually conducted in civil cases. So if you have a civil case, then you have a private investigation as well. A civil case can escalate to a criminal case. That's pretty intuitive. That, like was said earlier, that they're not sure if a crime was committed, but they're going to do an internal investigation first, gather some evidence, and if it warrants it, they will call on law enforcement to conduct the investigation further. A criminal case can be reduced to a civil case. Okay, so the guiding principle here is that the business must continue. So if you're helping a business do a private investigation, an internal investigation, your actions as part of that investigation can't disrupt the normal flow of business, right? So that's kind of an interesting requirement that is unique to private investigations. You think about public investigations, criminal investigations, they don't care if it's going to cost you lots of money if they have to seize your device. Well, they might personally care, but the law doesn't care, right? If it needs to be admitted as evidence, collected as evidence, sorry, we're going to take it from you, right? There's no hey, we're going to try to not disrupt your business processes as much as possible, right? Okay. Here's some examples of some corporate computer crime examples. I'm not going to go into them because number one, you can read, and two. Okay, so organization's responsibilities. Okay, so we talked about how there has to be a company policy that is broken, and that's what determines whether an investigation should happen. Well, the company has to be responsible for establishing those policies in the first place, right? They have to do some research, figure out what's acceptable use, what's not, and actually put it down in writing. If they say, well, if this happens, we want to be able to investigate and call on law enforcement. So this gets really interesting when you include bring your own devices, right? Tell me what this means. What does this mean? BYOD. Yes. So the Army has specific cell phones, exclusively iPhones, that they will issue to government employees. And with that phone, they can check their work email, right? But I can't pull out my Android phone and check my Army email, right? So the idea is I can, if I was able to do that, I would bring my own device. IT would probably install some things, do some other checks, and then I would be able to check my work email and things like that. There's no mandated device that the company issues. It's bring your own. That's what it means. So for companies that have a bring your own device policy, this gets even a little more sticky because you don't have full control over the device that your employees are using, right? If you issue everything that your employees use, if you're the one that issues them, you can say, okay, we're only going to buy this make and model of laptop or whatever it is, and that gives you tighter control, so it makes it easier to write policies for the acceptable use of that. You see what I'm getting at? Okay. Got clearly define what distinguishes private property and company policy. Display warning banners. I see something like this about a dozen times a day when I'm working on my work computer, right? You are accessing a U.S. government USG information system, IS. The use of this IS, yes, I just scroll. Okay, let me in, right? Okay, a few more things that I want to touch on about public versus private investigations. So public investigations search for evidence to support criminal allegations, whereas private investigations search for evidence to support allegations of abuse of a company's assets in criminal complaints, okay? So if there's anything from this past section that you need to remember, it's this slide, okay? All right, before we jump into the next topic, I'm gonna just take a few minute break and we'll start up again in a minute, okay?
even if it's in.
Okay, let's go ahead and get started again. I'm hoping that we will. I'm hoping that we'll get through almost the rest of this topic today, which will put us in a place where I can introduce the group project for the semester. Because the things that we're going to hopefully get to today are what the group project is related to. Okay, let's talk about the rules of evidence. So there are 4 rules of evidence that kind of underpin everything that we've been talking about as far as like the process, right? So we've got digital forensics is divided into 2 parts, right? The process and the deep technical knowledge, right? Rules of evidence underpin everything as far as the process goes, okay? So federal rules of evidence dictate that there are kind of these four: authenticity, admissibility, completeness, and reliability and accuracy. So let's talk about each one of these. First of all, authenticity. This authenticity actually determines whether or describes if we can explicitly link files and data to a specific individual and event. Okay, so it's not the cryptographic kind of authenticity that we were talking about last week, where if a message is authentic, then I can have assurance that you really were the sender, right? It's related, but we've got to be able to tell a specific story with the evidence. So usually what this uses is access control, logging and audit logs, collateral evidence. What is collateral evidence? What does that mean? A really fancy way of saying other evidence that's related and other stuff that's related. Crypto-based authentication, specifically if it provides non-repudiation. So if we have this cryptographic principle in place of non-repudiation, meaning that if I have a log that says you did this, there's no way that could have been forged, because we have the underlying assumption that no one else has your cryptographic key, right? So access control and logs, audit logs, those are going to show, okay, this person was logged in from this time to this time, and it's a single user system. So everything that happened on the system between those within that time frame, they had to have been responsible. Things like that. Okay. Admissibility. So all you got to know and remember about admissibility is that different regions, different countries, different areas of the world have their own laws about what can be admitted as evidence. I will not be requiring you to remember S24 CJA 1988. I will not be requiring you to remember that on the exams, right? Admissibility just means wherever the crime was committed, the laws that apply to that jurisdiction have to be followed for evidence. Okay. Moving on. So completeness. So evidence has to tell kind of a complete narrative of a certain set of circumstances. Okay. So in other words, you can't have the evidence be misleading in any way, right? There can't be gaps or holes that would lead a judge or a jury to an incorrect conclusion based on the story that the evidence is telling. So what that means is that, let's say that the defense says, I don't think this is correct. This isn't telling the whole story. I'm going to submit this evidence that makes the evidence more completeness, more not more completeness, more complete, tells it more of a complete story, and that has to be considered extemporaneously, like that big word. At the same time, contemporaneous. Oh man, I messed it up. I messed up my big word for the day. Contemporaneously with the other evidence. Okay. Yeah.
Quick question.
Sure.
What would happen in case somebody creates completely fake and they locals pick their law? Do they follow their laws or does it follow ours? Or do you just go back in the states for each edition? Do they differ enough that it matters?
So it totally depends, right? Because so you're saying that the crime was committed in the United States and then the perpetrator flees, right? So wherever the crime was committed, that's the jurisdiction where the rules apply. But here's the thing about our world. In the cyber world, there are no borders, right? I don't have to show a passport online to get to a server that's located in another country. That's not how the internet works. So drawing borders and jurisdiction boundaries is really difficult, and that's one of the most difficult things and unanswered questions about digital forensics is, what if you have a perpetrator in this country and a perpetrator in that country, they were using this server over in that country, and they were all attacking that country? Like, where is the actual crime being committed? It's a difficult question to answer, and as far as I know, they've taken that one case at a time and tried to do the best, right? So last week I mentioned a book, Fatal System Error, right? One of the interesting stories that they tell in that book is about these criminals that were in Eastern Bloc country that they had stolen millions of dollars, right? And the only way to get at them was to get them to come into a state or a part of Russia where there was an actual judge that they could trust. There was like one judge, but they had to get them over there. They had to get them to appear in court before they could actually get them. And so there's crazy things like that, government corruption is a huge separate issue that not only do you have jurisdiction lines that are totally blurry, but even if you can get over that hurdle, getting the government where that person is to cooperate with you, or, it's a mess, and it's really difficult. So there's no easy answer to the question that I think you were asking. Did I kind of answer it at least a little bit? Yeah, I guess I should check for understanding before I went off on such a long tangent. I apologize, but okay. Any other questions? Okay. All right. This is just a link to what I was talking about as far as evidence completeness. Okay, accuracy. So, okay, pop quiz. What do you think accuracy means in the case of digital evidence? Is anybody able to read it that fast? Yeah.
Maybe that the evidence wasn't tampered with.
Okay. So kind of the integrity of it. Okay. Kind of. No. Yeah.
Maybe like,
What do you mean though? Like correct in what way?
I guess it's kind of like the same.
That it wasn't changed after it was created? Okay. Yeah.
How correctly the narrative you construct from the evidence actually fits into what crime was committed or what.
Okay. So like the interpretation of the evidence, is that what you're thinking? Okay. Also wrong, but I love these ideas. Did you have your hand up? Oh, okay. Also wrong. No, just kidding. Yeah. Accuracy. What is accuracy? If I say this evidence is accurate,
The degree of confidence we have.
okay, keep going. I like that. Okay, so this is it. So you have to be able to say with some level of confidence that the computer system that created that data, that evidence, was functioning properly. So it's not the integrity of the content itself, but the system, the processes that created it, were they functioning properly? And can you prove that? So this is one of those areas where your deep technical understanding of computer systems comes into play, right? You can say, well, because we weren't able to find any rootkits or viruses on this system that we acquired from the suspect, we can say with a high degree of certainty that the file system timestamps are accurate, that they were in the time zone where the crime was committed, all of that. You see where I'm getting? What I'm getting at, sorry. Okay, so can we explain how an exhibit came into being? Like, what does a computer system do? What are the inputs to that system? What are the internal processes? What are the controls that dictate whether it's functioning properly? All of that. Okay, any questions? Yeah.
I'm trying to understand like, a little bit like bigger picture of what this actually is. This is a computer process that creates the content.
Yes.
So is that in terms of like, let's say a forensic is trying to find evidence and whether their computer is accurately depicting the evidence, or is that, let's say, a criminal making? I guess I don't fully understand.
Okay. Great question. Thank you. So I'm going to back up just a step. So these 4 rules of evidence are once you have the evidence in your possession. So we found the suspect. There was a complaint. That we started an investigation. We got evidence. We have possession of it. Now that we have possession of it, how do we make sure that we handle it properly? We have to follow these 4 rules of evidence because it's now evidence. We have to show that the evidence, the data that we're going to say proves this guy killed somebody, kind of important. It was the system was functioning properly when it created this evidence that we're saying incriminates that person. Is that clear? Clear that up? Okay. Good question. Thank you. I appreciate that. Yes?
So that'd be like if a logging system had to have like false positives in it, you wouldn't have accuracy?
Wait, what do you mean by false positives
Like
in
they
a logging system?
registered connections that didn't happen, and you couldn't prove that the connection you're using.
Yes. Yes. So logging systems are as far as like logging systems don't determine if something is one thing or another, right?
Yeah.
They just keep track of information that you give them. So an intrusion detection system is a little bit different, right? Where it has false positive and negative. It says this is suspicious or it's not, right? So that's a little bit different. But logs are important because you never want them to be altered by any process or user that doesn't have permissions, right? So that would be something you would look for is, was there some entity operating in the system that may have changed the log entries? That clear that up a little bit? Okay, good. I like these questions. Any other questions? Yeah, okay. Okay, this is a big one. Chain of custody. So, chain of custody, not the blockchain of custody, that's the group project, right? The chain of custody is what you are, so when you have possession of evidence, you have to keep track of everything that happens to that evidence. You have to be able to show exactly where it was stored, who had access to it, and when, what was done to it, all of that. So this form, it shows that the integrity of the evidence was not changed while it was in possession of law enforcement, while it was in possession of the forensic investigators. So if I want to analyze a piece of evidence, I can't just grab it off the shelf. I have to go over and log, okay, I'm Dr. Mike Maybe, I'm checking out evidence number, blah, 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 and this is part of case whatever, the date and time is this, and then I can take it and actually do something with it. Because with that log, we can show, okay, this was never out of our possession. It was not contaminated in any way by any of the forensic technicians because they followed all these other rules of evidence. And nobody was able to get to it to compromise it. Okay? Exactly. So it shows the route that the evidence takes from the time you find it until the case is closed or goes to court. Okay. Yeah.
So the example we were talking about earlier where the police officers, whatever, got that would this be a violation of that?
So they were violating the integrity of the evidence. Whether or not they logged it in the chain of custody form is kind of a separate matter. You see that? Yep, exactly. Well, if you turn a computer on, you've changed its state. All right, because Windows is always hitting the Windows registry, values are changing all over the system. You don't want that to happen at all when evidence is in your possession. We'll talk more about different kinds of precautions you have to take with that in the next topic. Okay. Any other questions about chain of custody? Okay. So next we're going to talk about time attributes, and in this setting, it's important mostly because we've been talking about how you have to make sure that the evidence's integrity is intact, and you always know when things are happening to the evidence. So this is kind of more of a file system topic, and so we won't get that until topic 4, I think. But time attributes, they help the investigator establish a timeline of what happened leading up to the crime or during the crime. So they're very important to an investigation. The acronym that you got to remember is MAC, or MAC. So what does that stand for? No. MAC, talking about times for digital files. Modified time. This is when the file was changed, when its content was changed. Okay. A, access time. Guess when that is? When a program actually reads the file. So this is all metadata that is tracked by the file system. So, and then C is change time. So this keeps track of when the file was changed. So what is the difference between modified and time and change time?
The change time has to do with like if you give it to if you set it has like a set UID bit, or if you transfer ownership of the file, that's a change time. Whereas a modified time would be like actually accessing the contents and then modifying the contents.
Yes. So the difference is in the metadata. So it keeps track of when the meta information about the file was changed. So if you change the name of the file, is that changing the contents? No. So the modified time, at least theoretically, wouldn't change when you rename a file, but the change time would change. You see the distinction between data and metadata? Okay. So the change time can be used as an approximate deleted time, or D time, for file systems that don't have that. Okay, any questions about time attributes? We'll revisit, oh, excuse me. We will revisit this when we talk about file systems. So, okay. All right. This is the last subtopic of this topic of slides. So we're doing good. We're going to talk about the forensic process. All right. So everything in this topic has been leading up to this. Super excited. I've got people like falling asleep. That's okay. So I understand that some of this material is a little bit more dry than you were probably hoping for from this class. But this is that first part of forensics, right? I told you that forensics is divided into 2 parts, process and deep technical knowledge. This is the process side. It's not as fun as the technical side. But the process side is what makes forensics, right? So we're almost there. We're almost there. All right. The way you remember the forensic process is AAA. Okay. So first one, acquisition, preparation, and presentation. These are just different names for the same process step. Okay. What you do in acquisition is you copy the evidence or the data without altering or damaging the original data or the seen where it was. Again, authentication. This is where we prove that the recovered evidence or the data is the same as the original. Analysis, examination, evaluation. This is where we actually try to find stuff that's on that device. We're looking for keywords or pictures or whatever it might be, okay? Okay, so how many steps are there to the forensic process? There's 4. So the last one is not part of AAA, but it's reporting. So this one is where you actually collect all the information that you've been gathering as you analyze the evidence, and you put it into a report for somebody else to consume. Okay, it's tricky, right? So how many steps are there to the forensic process? 4. How do you remember the forensic process? AAA. But you got to do acquisition, authentication, analysis. Oh yeah, then I have to write a report, right? It's like the afterthought. Okay, we're going to talk about each one of these a little bit more in depth. So acquisition, we talked about how, okay, before you do any acquisition, you have to make sure that you have permission to. Okay, if you're doing a private investigation, that's just a matter of checking the company's policies, right? If it's if a public investigation, you have to make sure that you've not violated the Fourth Amendment, that kind of thing. Then you have to figure out the purpose of the analysis and clearly define results. Okay, why? Why do you need to know what the purpose is before you even acquire the evidence? Let's go back to the Alexa murder investigation. What was the purpose of trying to acquire data off of the Alexa? Off of the Echo, yeah.
To see if it had recorded anything that may have implicated the suspect.
Exactly. So if that was your purpose, but you had a device that had no microphone, then it doesn't make sense to even acquire it, right? This is like your sanity check. Does it even make sense to try to acquire data off of this device? Okay, that's all I'm trying to say with this bullet point. Okay, all right. Then you need to ensure that you have all of the software tools necessary for it, and you have to make sure that it's widely accepted. Okay, you can't, in the forensics community, you can't just write your own stuff and then say, yeah, this is great. Well, you can't. One-off stuff is great, but then you have to show that your software works properly. You have to show that. So the FBI's turnaround time for getting like the newest version of FTK or whatever software is that they use it's almost a year, right? It has to go through a rigorous software testing process to make sure that that software functions the way it's supposed to, because they're going to put people in jail based on what they find using that software. Okay. Then this is the exciting part. I know you have to go through all the boring stuff to get to the exciting part, right? You make a forensic or an exact image of the target media. This is the actual acquisition. All this stuff is making sure you don't screw up this part. Okay. Fair enough? Okay. Authentication. Authentication protects the integrity of the evidence. It helps. This is where you maintain control until the final disposition. And you verify the forensic, or verify that it's an exact image. We will talk more about imaging and stuff in the next topic. Okay, but basically, this needs to happen concurrently with the acquisition. Otherwise, you're going to screw it up. Okay. All right, analysis. This is the bulk of where forensic stuff happens. Is the analysis. So, what do we analyze? All of this stuff. Operating system, services, file system, hardware, password files, all of that. We're going to analyze everything that we can get our hands on. Here's some issues. Access controlled systems, like if you don't have that cracking software that you need to get in, you might not be able to decrypt the hard drive or something like that, right? It might have a virus. It might be, the disk might be formatted. It might be corrupted. All of these things might inhibit you from doing your analysis. And so you just need to watch out for them. And again, analysis is something that we will talk about more in depth in the coming topic. Reporting and documentation. The purpose of this is to communicate what you find on the evidence. So it's got to be written so that non-technical people can understand it, right? Think of a jury of your peers. If they can't understand it, then you haven't done your job well, right? Got to be admissible in court. You've got to document everything, including the reason why you do anything, and all details of the scene, take screenshots, copy files, all the applications on the system. So reporting is, even though it's a little bit dry, it's so important that the textbook has an entire chapter devoted to just how to write a report so that it meets all these criteria that we were talking about. So report writing is actually pretty important, because if you can't communicate effectively the things that you found, what good did it do to actually find them? Yeah, what's up?
Can we skip over that chapter by chance? Or is that something we go over?
We're going to go over that chapter page by page. No, we're not. This is about as detailed as we're going to get on reporting and documentation. Yeah, so yeah. Okay. So again, how do you remember what the forensic flow process is? AAA, how many steps are there? 4, right? Acquisition, authentication, analysis. Oh yeah, then I have to write a report. Okay. Oh, guys, we're gonna make it. We're gonna get through the rest of these slides today. So I'm gonna fly through these last ones because they're so boring. Okay, you've got to have a systematic approach. Okay, we kind of talked about that several times last week, that to do things right, you got to have kind of a prescriptive way to say, do this, don't do this, right? That's what we're talking about when we talk about a model for forensic analysis, okay? The government has a lovely, uncomplicated model to follow, right? Okay, the things to take from this are preparation and extraction. What does that sound like? Acquisition. And then identification. What does that sound like? Authentication. Analysis. What does that sound like? Reporting. Those government guys, they come up with silly terms sometimes, but you never can be sure. And then I don't even know what that is at the end, but basically reporting. Forensic reporting, right there. There it is. Here's another process model. Actually, several. So CSE came up with this stuff. DFRWS, they kind of that workshop. They came up with something in 2001. NIJ came up with this in 2001. They adjusted it in 2004. Cohen came up with this. By the way, Cohen and CSE, those are well-known researchers in the digital forensics field. I'm not even going to attempt to pronounce this guy's name, but basically you've got all these things coming in and out, and a report. But you've got to do all these initial assessment planning, make sure you've got the correct resources, acquisition, all of that. You hope you're seeing a theme here, right? That they can be abstracted to those 4 things that I'm saying are the process and the model to follow. Yeah, this is just a reiteration of you've got to go through each one of these. So initial assessment, the case details. You need to know what you're looking for and why. Situation, okay. And then you're going to do some planning and figure out how you're going to go about the actual acquisition. And then don't forget the custody form, because, there's 2 types. There's a single evidence form and then the multi-evidence form. So this is a single evidence form. You can recognize it because it says this form is to be used for only one piece of evidence. So this tracks the history of just one item. Whereas this is like, okay, we went to this crime scene and we collected all these different items, up to 10 pieces of evidence. Planning, this is all kind of dry. Just remember AAA and then a report, okay? That's what I'm getting at after here, okay? Make sure you have what you need. Don't forget your storage bags and a good cabinet to secure everything so that your chain of custody is actually valid. And then you do all this stuff and make sure you get all the stuff. And then, oh yeah, don't forget that there's some risks. So you got to make sure to look, and then you're going to write a report. What's so funny? This is serious business. This is people's lives we're talking about. You got to have repeatable findings, right? If somebody can't go in and do the same analysis you did by following the steps that you documented, then we got a problem, mister. And then we got to have conclusive evidence. Did they or did they not commit a crime, right? And then you reach the last slide of the day. Woo! All right, we did it, everybody. Okay, so that is our introduction to forensics, okay? At a high level view, we went over the process. Next time, wait a second, wait for it. I'm going to teach you Python.
Yay.
Just a little bit, just for a little bit. And then we'll talk about some cool stuff. We'll see you next time, guys.